Today's lesson is on irrational numbers. We have so far in this unit learned about integers, we've learned about rational numbers, and now we're going into irrational numbers. So here is an irrational number. So how would you describe that number? What do you think makes a number irrational? Alright, so here is the irrational number definition. So definitely pause the video and write this down. The definition, it says numbers that cannot be written as the fraction a over b, in which a and b are integers. So what that means, 2 is an integer, 3 is an integer. These are numbers that cannot be written in that form. So what types of numbers cannot be written as fractions? It's a certain type of decimal, and they are non-repeating and non-terminating decimals. So let's think about that. A repeating decimal would be 0.3 repeating. So an irrational number doesn't repeat. And a non-terminating decimal, well, a terminating decimal is one that stops. So a non-terminating one is one that doesn't stop. So let's think about this. If it doesn't stop, it has to go on and on forever. But it does so without a repeating pattern. So these numbers would go on and on forever, but they're non-repeating. That is a decimal that cannot be a fraction, therefore it is irrational. Alright, so now we're going to come up with some examples of numbers that are rational, irrational, and integers. We've already kind of studied the left side of this chart, in which so all integers are rational because all integers can be written as fractions. So let's just write some examples. -2, 4, 7 over 1. All of these integers can be written as fractions. That's why they're rational. So now some rational numbers that are not integers. 1/2, 0.3 repeating, 0.54. So fractions, repeating decimals, terminating decimals, whole numbers. So now examples of an irrational number. You can start with just making a really long decimal. 2.7892235 4 2, showing dots that it's going on and on forever and it's non-repeating. Now some famous irrational numbers would be pi, which we know is 3.14, but it's 3.14159, and that goes on and on forever. And we'll get into later this unit on a lot of square roots. Not all square roots are irrational, but square root of 2 is irrational. Square root of 3 is irrational. The square root of 4 is actually an integer. So this is classifying all three types of numbers. Alright, just reiterating one more time because this is kind of important vocabulary. A repeating decimal, 0.22 repeating, is rational because it can be written as the fraction 2/9. A terminating decimal, 0.12, can be written as a fraction because that would be 12/100ths, which we could then simplify. So now a non-repeating, non-terminating. Can't repeat and it never ends. 2.47689211523 dot 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 dot. Random numbers. A decimal that goes on and on forever that is not repeating. All right, and the last part of these notes, and for your assignment, if you're given a number, you have to determine if it's rational or irrational and be able to explain why using the vocabulary. So let's start with negative 0.05. This number is rational. And why is it rational? Look at the decimal. The decimal terminates. It is a terminating decimal. All right, the next one, pi over 2. This is kind of a trick question because it looks like a fraction and all fractions are rational. However, to be rational, it's in the form a over b, in which a and b are integers. So like 1 over 2, 3 over 4. But anytime pi is part of the number, automatically makes that irrational. And then to describe why something is irrational, you got to use, it's irrational because it is non-repeating, and it's both non-repeating and non-terminating. All right, third example, let's do 0.123 repeating. That decimal goes on and on forever, but it's rational. Why is it rational? Because it's a repeating decimal. Last example, 0.202002000. So I kind of went into the other column a little bit, but the dots show that it's never ending, it's non-terminating. And as you can see here, there's kind of a pattern to it, but it's not the same exact numbers repeating over and over and over again. So it's irrational. And why is it irrational? Because it's non-terminating and non-repeating. So there's your full lesson on irrational numbers. Good luck.